Have you ever wondered about the applications of physics in real life? Here I have analyzed a movie scene from The Amazing Spider-Man. As you can see, the scene begins with Spider-Man stranded on a roof. Too difficult to know for exact, I've estimated the length of this rooftop to be roughly 75 meters. At this point, Spider-Man will begin running off the roof. As we know, the initial velocity is 0 because it's in rest. The estimated distance I got was 75 meters, and the time it took was 9.9 seconds. And using these values, I got the acceleration is 1.53 meters per second squared, and the final velocity is 15.2 meters per second. This is equal to 54.7 kilometers per hour, which I find to be very unrealistic as this is faster than Usain Bolt. Using Andrew Garfield's reported mass being 74.8 kilos and the acceleration we already have, we can find the net force, which is 114.4 newtons. Using the values we already have, we can find the work, which is 8,583.3 joules in this case. In this scene, although a particular height isn't given, I would assume that this building is around 80 meters tall. This scene is an instance of projectile motion when Spider-Man jumps off the roof. And using all the values we have, we can find delta dx, which is the horizontal displacement, which turns out to be 250 meters as it can seem through the video. But I would say that's rather unrealistic as factors such as air friction haven't even been considered. At this point in the Spider-Man scene, Spider-Man lucks out as he ends up landing on a crane hook, which ends up pulling him upward. At this point in the scene, there are two forces present, the force of tension from the rope pulling Spider-Man up, and the gravitational force as always. This clip in the Spider-Man movie scene proves Newton's third law of motion that there's always a force in the opposite direction of equal magnitude because Spider-Man needs to push down to push himself up. Although difficult to know for exact, I would predict that this took 2 meters for Spider-Man to pull himself up. Using the kinematics equations, we can determine the acceleration of this motion, which turned out to be 0.17 meters per second squared. In this scenario, there are two forces acting upon Spider-Man, the applied force and the gravitational force. Using the MA formula, I got the F net to be 12.9 newtons, and I substituted it to get the applied force to be 745 newtons, which was what Spider-Man needed to pull himself up. Now that we have a hold of the force it took and the distance, we can use the FD formula because this is on a 90-degree angle, and I got the work to be 1490 joules. As you can see now, Spider-Man will pull himself using his spider webs. In this scenario, the force of tension pulls Spider-Man towards the crane, and there's air friction which is present in this, and there's gravity as always. When Spider-Man jumps up the crane hook in this clip, although it's hard to know for sure, I would estimate to be around 70 meters in height. As we can see in this frame, we can see that the web is slightly at an angle. I would assume this is around 10 meters lower than the starting position. In this clip, I'll use the mechanical energy formula to determine the speed of Spider-Man in this frame. Using the gravitational value, the height that I estimated, I can use that to find the mechanical energy for both. Using this formula, I've managed to determine the velocity that Spider-Man was at this point of time, which ended up to be 14 meters per second, and personally speaking, I think that's realistic for how fast it was shown in the scene. Using the same mechanical energy formula, I can calculate the height at which Spider-Man is at its peak. Using all of the given values, I'm able to make an equation for mechanical energy 1 and mechanical energy 2. So this way, I'm able to calculate delta H2, which is 70 meters, but in comparison to the movie, this is false because it's shown that Spider-Man goes higher than it initially was, which simply isn't happening according to this equation. Now Spider-Man begins free roaming. At this point, Spider-Man is the closest to the ground as he will be in the scene, and now let's calculate the velocity of him at this point using the law of conservation of energy. As we can see in this frame, Spider-Man is slightly above the city lights, which are on average 3.5 meters tall, so I would say Spider-Man is around 4 meters in the air. So once again, using the mechanical energy formula, I substituted all of the values I got, and I ended up getting that Spider-Man travels at 35.9 meters per second, which, let's be real, it's very unrealistic as that's a very fast speed as to what's shown in the clip. Anyhow, having said this marks the end of the movie scene, and I think it's time to recap all of the unrealistic moments and my overall opinion on this. First things first, according to my calculations, Spider-Man runs off this roof at 54.7 kilometers per hour. And let's be real with ourselves, that is really unrealistic because this beats Usain Bolt's record, and Andrew Garfield is no athlete, he's a actor, and I would never expect an actor to go this fast. Another unrealistic moment in this movie scene is when Spider-Man actually ends up running off the roof. He ends up going a far distance as opposed in the film, and according to my calculations, he ends up going nearly 250 meters, which is a really far distance, and considering that air friction wasn't even considered, I would say running 250 meters away through projectile motion is rather unrealistic, especially when you're running faster than Usain Bolt. Additionally, another unrealistic scene in the Spider-Man movie scene is when Spider-Man begins swinging. When Spider-Man begins swinging, all of this swinging leads to unnecessary and unrealistic speeds, and on top of that, all of the heights that were proposed in the movie would not have happened in real life according to my calculations, which is why I don't think this would happen in real life. At this point of time, the question approaches me: would this movie scene have happened in real life? The answer to this question remains clear to me, and it's absolutely not. There were instances of Spider-Man running off the building, the projectile motion of his fall, and him swebbing around the city, and this was without factors such as air friction, which can make an immense change. So my final answer is, this is a movie scene, don't take it to heart, don't try these things at home, and let things that happen in movies happen in movies, because that's how things are sometimes.